Hello students. Welcome to our Senior Secondary School 2 Physics lesson. Today, we will be learning about machines, but before we proceed, let's quickly recap what we learned in our previous lesson. In our previous lesson, we defined uniformly accelerated motion. We explored the three equations of motion. We also went ahead to solve some calculations on uniformly accelerated motion, and I hope you learned something. Before we begin today's lesson, let's take a quick look at our lesson objectives. In this lesson, we aim to achieve some key objectives. First, you will learn what machines are. Then, we'll identify various types of simple machines. We'll also explore mechanical advantage, velocity ratio, and efficiency. Finally, we'll solve some numerical problems to apply these concepts. Are you ready? Let's dive in. Have you ever used a tool that made your work easier? Like opening a bottle or moving something heavy? These are things that machines help us do. With that being said, let's find out what a machine is. A machine is any device that simplifies work. It makes work easier and stress-free. Its primary purpose is to help overcome a larger force, known as the load, by applying a smaller force, called the effort. They achieve this by magnifying force, changing its direction, or increasing speed. Common examples include scissors, spanners, and jacks. Types of simple machines. These are the types of simple machines: lever, inclined plane, pulley, wheel and axle, hydraulic press, screw, and wedge. We will be exploring some of these machines in this lesson. Let's go. Now, let's discuss the three key parameters of machines. 1. Mechanical advantage. It is the ratio of the load to the effort. It is defined as MA equals L over E. L in this case is the load, and E is effort. 2. Velocity ratio is the ratio of the distance moved by the effort to the distance moved by the load. It is defined as VR equals X over Y. X is the large distance, and Y is the small distance. 3. Efficiency. The ratio of useful work done by the machine to the total work put into the machine is called the efficiency of the machine. It measures how well a machine performs, expressed in percentage, and is defined as efficiency equals MA over VR times 100%. In an ideal machine, we assume that the mechanical advantage is equal to the velocity ratio, and the efficiency is 100%. This means there is no energy loss in the system. Let's see the classification, uses, and applications of machines. 1. Lever. It is a rigid bar that pivots around a fixed point, called the fulcrum. An effort is applied at one point on the lever, and this overcomes a load at some other point. Levers are classified into first, second and third order levers. The first order lever type is one which the fulcrum is between load and effort. The direction of the effort is opposite to the direction of the load. Examples are claw hammer, crowbar, and plier. It can provide a mechanical advantage greater than, less than, or equal to 1. The second order lever. Here the load is between the effort and the fulcrum. Effort and load move in the same direction. Examples: wheelbarrow, nutcracker, and bottle opener, etc. It always provides a mechanical advantage greater than 1. It requires less effort to lift a heavy load. Third order levers. This is a lever where the effort is between the load and the fulcrum. Effort and load move in the same direction. Examples: forearm, tweezers, and fishing rod, etc. It always provides a mechanical advantage less than 1. It requires more effort but moves the load faster over a larger distance. The formula for mechanical advantage of lever is mechanical advantage equals effort arm over load arm. Now the second type of machine. Pulley. A fixed wheel with a groove around its edge, used with a rope or cable. A load is attached at one end of the rope, while the effort is applied on the other end. Examples: flagpole, crane, and well bucket system. System of pulley. Pulleys can be combined to form machines, used for lifting loads. They are used by builders for hauling heavy loads to high floor, or in loading and unloading ships. The aim of combining pulley is to achieve a higher velocity ratio and also a higher mechanical advantage. The third machine. Inclined plane. It is a flat surface set at an angle to the horizontal. It reduces the force needed to lift objects, by increasing the distance over which the force is applied. Heavy loads, such as drums of oil and engine blocks, can be raised with the aid of the sloping plank with little applied effort. This arrangement is called an inclined plane and is said to be a machine. Examples: ramp, slide, loading dock, etc. Seeing all that machines can help humans do, I can say that machines make the world a better place. Now it's your turn. Here are 2 quick practice problems. Give them a shot. Remember to pause the screen and solve the problem. Great job so far. Let's recap what we've learned. Machines make work easier and faster. Examples of machines are pulley, screw, wheel and axle, inclined plane, and lever. In our next lesson, we will be learning more about machines. Well done. You've come to the end of this lesson. Stay focused, and I'll see you in the next lesson.